All right, so please be quiet. So we're going to look at the parent functions for cosecant, secant, and cotangent. Now, we just did some work on Desmos to get a sense of what the picture looks like. So now we're just going to put it on a graph so we can understand. So I'm just going to go direct with you, okay? Cosecant starts with an asymptote. So you need to get a different color probably. Maybe I need it too. I'll do it in green. So we're going to have an asymptote. That's what it starts with. Then, in the middle, at pi will also be an asymptote, and at 2 pi will be an asymptote. When we graph it with transformations, we're going to start with an asymptote, we're going to end with an asymptote, and then in the middle will be a third asymptote. That's how it's going to start with when we graph with transformations. In between the first two asymptotes is a point of reflection at positive 1. This curves up in both directions. I said it's a little bit like a parabola. It's actually flatter than a parabola. I'm not going to judge it. I'm going to judge that this is a turning point and that it goes up in both directions from that. The next two asymptotes, we have a turning point at negative 1, and this one folds down. And that pattern repeats over and over and over again. So I'm going to repeat it to the left as well, find where the asymptotes are, and make sure that your curves, your turning points, aren't right beside each other. They have to oscillate. One up, one down. One up, one down. If you notice two of them are beside each other, like there's two curving up beside each other or two curving down beside each other, then the pattern is off. And if you look to the left right there, you know what you do? You see your soul when you're doing trigonometry. See how it looks at you? How do you feel when you're doing trigonometry? Right there, right? Like you can see the picture, right? Reflecting back at you, the sad little face, right? Does no one else see a sad face while doing trigonometry? All right. So, the domain for cosecant is all real numbers except multiples of pi. The range is all real numbers from 1 to infinity and negative infinity to negative 1. The x-intercepts, there are none. It doesn't touch the x-axis. And there's no y-intercepts because it doesn't touch. There's an asymptote over the y-axis. Where are the asymptotes? At every multiple of pi. There is no amplitude because it's not a wave. And what's the period that completes one cycle? So one cycle is one curve up, one curve down, and then the cycle's done. So it needs both up and down to complete one cycle. If you have a transformation, let me just expand the camera a little bit. So for the bottom part, there is no amplitude. If you have a transformation, you would start with 2 pi, and if a number is being multiplied inside, you would undo that number inside. So the period then would be 2 pi divided by whatever that number is. This guy just represented with B. How do you know if there's a phase shift or not? So if you have adding or subtracting, right, and it's the opposite sign, right, goes in the opposite direction. And then the vertical shift is just what K is. Next, Secant. Secant starts with the turning point. Secant ends with the turning point, and then in the middle is another turning point that's going to turn down. In between those turning points will be asymptotes. So when we're graphing cosecant, we're starting with asymptotes. When we're graphing secant, we're starting with turning points. This is going to curve up. This is going to curve down. And then we repeat that pattern as much as we need to. So you can see the picture of secant and the picture of cosecant look similar. But what's the difference is where they start. Cosecant starts with an asymptote. Secant starts with a turning point, and you will remember it by practicing and studying. The domain is the same domain as cosecant. It is all real numbers except, actually it's different, except multiples, odd multiples of pi over 2. Not the same. Now, why do I say the word odd multiples? Because even multiples would be 2 over 2 or 4 over 2. That doesn't work, right? Even. It has to be odd. So we have 1, 3, 5, 7. So it's odd multiples of pi over 2. That's where the asymptotes are. The range is the same. That's what I meant to say. So it's all real numbers from 1 to infinity and negative infinity to negative 1. X-intercept, none. But there is a y-intercept at positive 1. So it just crosses the y-axis. But it doesn't touch the x. We have asymptotes at every odd multiple of pi over 2. There is no amplitude because it's not a wave. And how long does it complete to complete a cycle? It takes 2 pi, 1 full circle. When this function is being transformed, there is no amplitude. The period would start with 2 pi, and then you would undo if there's a number being multiplied inside. The horizontal shift or the phase shift is h, and the vertical shift is k. 1 left. You don't want me to call you out? There's 1 left. And then we got to practice. And then you got to do your homework. It's all real numbers from 1 to infinity. That means the numbers 1/2, 1/3, 1/4, negative a third, negative a quarter, negative a fifth, negative an eighth, 1/8, 1/10, negative a tenth. There are numbers between negative 1 and positive 1 that are not 0. Yes? Okay. Here we go. Last one, then we get to practice. This is obviously for your reference sheet because you forget, right? You want this in your notes to go back to. So the last one is cotangent. So what does the function cotangent look like? What does it start with? So cotangent starts with an asymptote. And it takes only to pi to complete a cycle. For 0 to pi, that's it. 2 asymptotes. That's 1 cycle. In the middle is going to be a point of inflection. The first asymptote to the point of inflection, we go to positive 1, and it curves up through positive 1. So it goes up to the left. In between the point of inflection and the next asymptote, we find negative 1. And we curve down. And we follow that pattern over and over and over again as necessary. So for cotangent, like cosecant, and you are going to remember the cos start with asymptotes. Cosecant, cotangent start with asymptotes. That's what the cos do. Then you have a point of inflection, and then you put in the points you curve through negative 1 and positive 1, and you know it goes up to the left and down to the right. The domain here is the same as cosecant. So the domain is all real numbers except multiples of pi. The range is like tangent. The range is all real numbers. Every number is in the range. It goes up forever and down forever without any breaks. There's a bunch of x-intercepts. So at every odd multiple of pi over 2, there's an x-intercept. It crosses the x-axis at every odd multiple of pi over 2. There is no y-intercept. Asymptotes are at every multiple of pi. There is no amplitude. And the period for cotangent is pi, just like tangent. And then what happens when there's transformation? There is no amplitude. The period is pi, but then if there's a number being multiplied inside, you have to undo it. So you divide to find what the period is. And the horizontal and the vertical shift is h and k. And now you have your reference sheet. So when you're ready, turn the page. And how we learn is by practicing. All right. What happened? What happened? Oh, did I put tangent? Yeah. Thank you. That should be this. C-O-T. Thank you. Though if it said tangent, it would be the same way exactly in terms of transformations. It just started at a different spot, curves differently. All right, turn the page. Here we go. Let's just start here. What's the period of cosecant and secant? And the answer is 2 pi. What's the period of cotangent? And the answer is pi. You can see the pictures above if you need a reminder of what it looks like and where it starts with. So, let's start with number 1, and let's graph it together. So, to start with, what function do we have for number 1? Cosecant. What's the period for cosecant? 2 pi. Is there anything inside the function that would change that? No. Now, what does the number in front give us? And I want you to think that's going to give you your upper vertex and your lower vertex. So 3 divided by 2 is 1.5. And your lower vertex then would be negative 1.5. So where are your turning points now? That number in front changes where you put the turning point. All right, cosecant starts with an asymptote. So we're going to start with an asymptote. Then we're going to go to the end of the period. So 2 pi ends this cycle. So at 2 pi is going to be an asymptote. And then in the middle there is going to be a third asymptote. And that completes all asymptotes for the cycle. That's how we're going to start graphing it. Look at the first 2 asymptotes. We need a turning point in the middle. It's important that cosecant is positive. Because cosecant is positive, we're going to start with an upper vertex. And this folds up. And then the next one's going to be a lower vertex, and it's going to fold down. And that's the pattern we're going to go back and forth with. So now we're going to complete the pattern and complete the turning points. And make sure you recognize the turning points oscillate. Number 2. All right, what function is number 2 is secant? And normally the period for secant is 2 pi. Is there anything multiplying inside that would change that? Yes, 4. How do you undo multiplying times 4? And 2 pi divided by 4 is pi over 2, or 1/2 pi. All right. Secant starts with a turning point, a vertex. And what number will our vertex be? So can you find where positive 2 is? And that's where we're going to start. If 2 was negative in front, where would I start instead? Negative 2. But we start at positive 2. Can you go to the end of the cycle? And what's going to happen? And where's our end of the cycle? At pi over 2. That ends one cycle. There's going to be a lot of mini parabolas up and down here. In the middle between that is going to be a lower vertex, a lower turning point. So for secant, I start with 3 turning points. Above, above, and then one lower. Now in between, in the middle of the boxes, is going to be asymptotes. In the middle of the box. These are going to be really tiny little parabolas up and down. That's the pattern. I'm not going to go forever left and right. I'm just going to do part of the pattern. You get the idea. We don't need to do 10 of them. So I'm just going to end there. And note that the upper ones are skinny looking little parabolas going up and little ones going down. So the upper vertices fold up and the lower vertices fold down. And that little is going to go forever left and right. Because the period got shortened so much, there's so many little parabolas going up and down in a short amount of time. All right, number 3. Number 3 is secant. Normally, the period for secant would be 2 pi. Is there a number inside that would change the period of this function? Yes. How do I undo a fraction? And the answer is times the reciprocal. If I reduce this down, I get 3 pi over 2, because 2 goes into 4 2 times. I want you to notice in front is what number that you don't see in front of secant. -1. That's important. Secant starts at the turning point. And our turning point is going to start with -1. It's going to start at the bottom because of the negative sign. So because it's negative, it starts at the lower turning point. Then I go to 3 pi over 2. That's like 1.5, yes? So 1.5 is also going to be a low turning point. In the middle between these, and I went 6 boxes to the right. So in the middle would be 3 boxes. I'm going to find +1. And then in the middle, between the turning points, are going to be asymptotes. And there's the pattern. This asymptote is in the middle of the box. And I'm going to follow that pattern and then complete the curves. All right, once you have the asymptotes in, then all you have to do is complete the curves. The higher vertices curve up. The lower vertices curve down, and you've drawn the graph. I'll give you a moment. We're at number 4. I'm not going slowly because it's on video. So if you need to go over it again, you can. Number 4 is cosecant. The normal period for cosecant is 2 pi. Is there a number being multiplied inside the function that would change the period? Yes. How do you undo multiplying times 2? Divide. And when you divide, what's the answer? Pi. Now, cosecant starts with an asymptote. And then at pi will be an asymptote. That will complete the cycle. In the middle will be another asymptote. We need 3 asymptotes to begin with. Exactly in the middle. Now we can start our cycle. 5 divided by 2 is 2.5. And because it's positive, we start with 2.5, that's above. Then we go to negative 2.5, and the upper vertices fold up, and the lower vertices fold down. And that's the cycle. And you repeat the pattern as much as you need. So again, I'm finding 2.5 and negative 2.5. And the lower ones fold down and the upper ones fold up. When you're ready, turn the page. I have another video so you can practice with me with the homework. And you can press pause as much as you need to. Here we go. Number 5. Now we're graphing cotangent. What's the normal period for cotangent? Pi. Is there any number being multiplied inside? Yes. How do I undo it? Divide by 2. Cotangent starts with an asymptote. So at 0, we're going to start with an asymptote. And then at pi over 2, it ends the cycle. Cotangent only has 2 asymptotes to end the cycle. Cosecant and secant have 3 asymptotes. All right, in between here will be a point of inflection, and that's at 0. And then you might think, what does the 3 do? The 3 changes the point that you curve through. So, in between the first 2, the asymptote and the point of inflection, go up to 3 in the middle. And put down a point. Curve up. It goes up to the left. Then the next point of inflection to the asymptote. In the middle, go down to negative 3. Curve down. And that's one cycle. You repeat that over and over and over and over again. So put in the asymptotes. Once you have your asymptotes, the point of inflection is at 0 all the way across. And then the points we curve through. So find positive 3. And then find negative 3. All right, number 6, when you're ready. I'll wait just for a moment. If you're going to remember how to graph all 6 trig functions, it's not going to happen by accident. Study, work, practice, ask questions, and don't give up. That's how you're going to learn it. Number 6, for cotangent, normally the period would be pi. So that's what I'm going to write down. Is there any number inside that's being multiplied? How do I undo 4/3? And that's just 3/4 pi. That's where how long it will take to complete a cycle. So cotangent starts with an asymptote. That's what I'm going to do. Then I'm going to find 3/4. I want you to remember that every square is 1/4. So 1/4, 2/4, 3/4 is just 3 to the right. So every 3 is going to be an asymptote. Every 3 is going to be an asymptote. Why not fill them in right away? Count 1, 2, 3, asymptote. 1, 2, 3, asymptote. In the middle between them, and it will be in the middle of the middle box, in the middle of the middle box is going to be a point of inflection. So in the middle of the middle box will be a point of inflection, like 1.5, right? In the middle. Then, what do you notice in front of cotangent? The number you don't see is what number? -1. So when I look at the first asymptote and the first point of inflection, now it's going to go to -1 and then to +1. So what did the negative in front do to my curve? The negative in front now cotangent's going up to the right and down to the left. So, do you know why now it curved in the other direction? Why it went up to the right and down to the left? Because cotangent was negative in front. It reflected it. All right, 3 more to do, and our lesson's over. You get a chance to get extra sleep tonight and be on your A game and not your sleep game, right? So number 7. Some of you guys are alert, some are not. Number 7. Here we go. You ready? What function are we graphing for number 7? Cosecant. The period for cosecant is 2 pi. Do you see anything multiplying inside that would change that? No, it stays 2 pi. Do you see anything adding or subtracting inside? There's a phase shift. So we change. It's the opposite direction. So it's going to be positive pi over 4. I'm going to circle it because that tells me where I'm going to start my graph. I'm starting now at pi over 4. Vertical shift. Is there a k on the outside? And it's -2. So our midline now is at -2 in terms of finding our vertices. So I'm going to do this work before I start graphing. If I would ask you where's normally our upper vertex? What number do you not see that's in front for my upper vertex? Positive 1, but everything is being shifted down 2. So now what number is my upper vertex if you go down 2? So negative 1. How about the lower vertex? Normally the lower vertex would just be the opposite number, which is negative 1. But again, it's being shifted down 2. So now where's my lower vertex? And now we're ready to graph, if we can understand those numbers. Cosecant starts with an asymptote. So at 1 over 4, can you draw an asymptote? Next, we're going to end the cycle. So 2 pi to the right, 8 boxes to the right. Can you end the cycle? And then in the middle, which is 4 to the right, will be a third asymptote. And those 3 asymptotes are part of the cycle. One cycle. Cosecant's positive. So we start with an upper vertex, but our upper vertex is at negative 1. So remind yourself, even though it's a negative number, it's still folding up. And then when we go the lower one, it's going to fold down. And that's the pattern we're going to repeat on the left side. All right, 2 more left for us to do. So finish this graph. If you know that you had a hard time this morning getting to school and thinking and working with me, then you might have extra work to do to look at the lesson again so that you are caught up and not just shrug it off and I'll fail the quiz tomorrow, right? So you might have extra work to do in terms of going over the lesson again when you're alert and you feel like you're ready to learn this. So 2 more left, number 8 and number 9. Let's start. Secant. The normal period for secant is 2 pi. Is there a number being multiplied inside that would change that? So what's the reciprocal of it? And if I reduce it down, 6 over 8 is the same as 3 pi over 4. The phase shift. Is there something adding or subtracting inside? What's the opposite direction? So where am I going to start my graph? At negative pi over 4. Is there a k? And that means everything has been shifted up 1. So my upper vertex would be positive 2, but because it goes up 1, it's now at 3. My lower vertex would have been at negative 2. But because everything goes up 1, it's now at negative 1. So when I go to my graph, I know where to go to. Secant starts with the turning point. And because it's positive in front, we're going to start at 3. So can you find negative pi and 3? That is where I'm starting. The phase shift and positive 3. My period is 3 pi over 4, which is 3 boxes to the right. That's also going to be an upper turning point. And then in the middle of the middle box is going to be the lower turning point, which is at negative 1. And in between those turning points are asymptotes. That's the pattern we're going to follow. So I'm going to go 1, 2, 3. 1, 2, 3. And then in the middle, at the bottom. So be a good rule follower. Be good with patterns. And remember, the upper ones fold up and the lower ones fold down. All right, the last one for our lesson. Number 9. Here we go. Cotangent. The period for cotangent is pi. Is there any number that's being multiplied that would change the length of that period? And the inverse of that is to divide by 2. So now the length of one cycle is pi over 2. The phase shift, go in the opposite direction. So I'm going to positive 3 pi over 2. The vertical shift is negative 3, which means everything's been shifted down 3. Normally, our point of inflection would be at 0. But because we have a shift, our point of inflection now is going down 3. So when we do our point of inflection, it's going to be at negative 3. And notice the number in front of cotangent. That means our turning points will be at negative 2 and at negative 4. We're going to go up 1 and down 1 to curve through when we have our pattern. Cotangent starts with a asymptote. So at 3 pi over 2, which is 1.5, we're going to have an asymptote right there. Our period is pi over 2, which is 2 boxes. So 2 boxes to the right, 2 to the left will be asymptote. So every 2 boxes is an asymptote. Now, in between that will be point of inflections, exactly in the middle, and that will be at negative 3. So in between the asymptotes, I need to find negative 3. Now, to curve through. Cotangent is going to go up to the right and down to the, or up to the left and down to the right. And so we're going to go to negative 2 and curve up, and then negative 4 and curve down. Negative 2, curve up, negative 4, curve down. Over and over and over again. And then you've graphed cotangent. Using transformations too. All right, there's your lesson on graphing cosecant, secant, and cotangent. Mr. G Math over and out.